Okay, in this lesson I want to look at developing some formulas for rectangles and right triangles. Just areas. I'm going to be talking about areas specifically. To find the perimeter of something, you just measure the distance around this outside. What length? I'm just going to really be talking about area here. The first thing is just the definition of what we call a unit square. And a unit square is just a square with side of length 1 unit. Okay? The area of this is said to be 1 unit squared. Okay, so that's just a unit square. It's a side of length 1 unit. If I want to look at a rectangle where we've got a side of length 3 and a side of length 4, and I want to find the area of this rectangle, what I want to do is I want to think about how many of these unit squares could I fit in. And the number of unit squares that I could fit into this shape are here. You know, there's 1 unit square, there's another. I've just filled it with these unit squares. Remember, a unit square is a side of length 1 unit. A square with a side of length 1 unit, so each of those is 1 adding up to 3, and 1 across adding up to a total of 4. Just counting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 unit squares here, so we say the area of this rectangle is 12 units squared. So that's the area of the rectangle. Of course, I don't want to be counting every time. It becomes a bit of a nuisance if I had, a million squares in there. I don't want to start counting a million squares. So we just develop a kind of an idea that if I know that there are 3 rows here and 4 columns, well, we can count. There's 4 across, and another 4 is 8, and another 4 is 12. So we're just taking 3 of these 4s to get 12. So we could have said the area is equal to 3 sets of 4, of course, which gives me the same result, 12 units squared. I could, of course, counted the number of columns, 1, 2, 3, 4. So I could have said the area is equal to 4 times 3, which gives me the same result, 12 units squared. But the key detail is we're multiplying the number of rows by the number of columns here. In other words, we're multiplying the length of it by the width of it. So to find the area of a rectangle, we can just multiply the length by the width. Here again, without putting in all the unit squares, I can see that I could fit 10 kind of across, 5 down. So the area here would be, well, we'd have 5 sets of 10 unit squares in here, which would be 50 unit squares. Okay, so the area is 50 unit squares. The key detail is to understand that the area is equal to the length by the width. Sometimes you'll see that written as base times height. Okay, depending on where you're looking at it. But one of the dimensions times the other. For a rectangle, really straightforward to be able to find that. Sometimes you'll be given the area, sometimes you'll be asked to find one of the dimensions. Here I'm given an area of 36. I'm given a length of 4, and I'm trying to find this base length, this b here. So we know from our formula that a is equal to length by width. So I'm going to substitute in here 36 on the left for a. I'm going to substitute in 4 on the right for L. And what we're looking for then is the width, which we've called in this picture b. So 36 is equal to 4b. What I'll do here to find b is just divide on both sides by 4. If both sides of an equation are divided by the same quantity, then the 2 sides remain equal. So I'm going to get 9 is equal to b. Or b is equal to 9. Units in this case, not units squared, it's just a measure of length. Another way to think about this, we spoke previously about these little silly triangles. If I know the area is equal to the length by the width, I can write that in 3 different ways. Area is equal to length by width, or the length is equal to the area divided by width, or the width is equal to the area divided by the length. So here we're trying to find the width. using this version of the equation of the formula, the width is equal to the area 36 divided by the length 4, which is 9. Again, the same kind of idea, 9 units across. What about the area of a right triangle? Suppose I want to find the area of a right triangle. Slightly more complicated because it's not a rectangle. However, one thing I can do, every right triangle is exactly half. Oops, sorry, let me try that again. Every right triangle is exactly half of a big rectangle that has been cut along the diagonal. So the area of this triangle will be half the area of this big rectangle we've just drawn. So this area in here, let's call it A1, will be exactly equal to this area 2. The diagonal here will divide it into two congruent parts. So the area of the triangle is going to be half of the area of the big rectangle. And to find the area of the big rectangle, we multiply the base by the height, half of 10 by 5, which is 25 units squared. So the area of the triangle, where it's a right triangle specifically, the area of a right triangle is always half the area of the corresponding rectangle. Another way to think about that is that the area of the rectangle is just double the area of the corresponding right triangle that has been cut out by drawing in a diagonal. Okay, so we're gathering little formulas as we go. So we have the area of a rectangle is equal to length by width. So the area of a right triangle is just half of the length by the width. The area of a triangle, usually we use, instead of length and width, when we're talking about triangles, we use the words base and height. So the area of the triangle is half the base by the height. Why? Because a right triangle is exactly half of a rectangle, like so. Okay, exactly half of a rectangle. So if it's a right triangle, it's half of a rectangle. So the area of a right triangle will be half the area of a rectangle, the corresponding rectangle. So area of rectangle is base times height. Try that one more time. Base times height. That's the area of a rectangle. The area of a right triangle is half of the base times the height. Okay, so know those formulas. Get used to trying them out. In our next class, we'll start looking at formulas for parallelograms and all triangles, not just right triangles.